So hello everyone, so today we are going to see this problem called AquaMoon and strange sort from CODEFORCES round 732. So initially we have AquaMoon has n friends and they stand in row from left to right, and the ith friend has the ith friend from the left wears t-shirt with the number A written on it, and each friend has a direction. So they have a direction like which direction they are facing, something like that. And in the beginning the direction of each friend is right. So initially all these friends will be facing towards the right, and AquaMoon can make some operations on friends. On each operation AquaMoon can choose two different friends and swap their positions. After each operation the direction of the chosen friends will get flipped. So he can swap any two friends facing to any directions, and if two adjacent persons are swapped, for example say one is facing towards left and another one is facing towards right, they get swapped, and if they get the position swapped, and also their directions will get swapped. Like the person who is facing towards left will be now facing towards right, and the person who was facing towards right will be facing towards left now. So this is basically the operation. Each one operation is defined like this, and AquaMoon hopes that after some operations the numbers written on the t-shirt of n friends from left to right become non-decreasing. So we basically we need to sort the friends numbers on their shirts, and after all these things we should also have another condition, like all the friends direction should be as initial, like they should be facing towards right. So we need to find whether it is possible or not. So we will be given n, which is number of friends. So we will consider this as an array, and the array elements as the t-shirt with the number AA, and we have elements with ranging from numbers from 1 to 10 power 5. So this is nothing but 4 says that there are 4 elements in 4 persons, which is nothing but 4 elements in the array, and the next 4 this is the test case. So first we will break this down, like so how these things will get this will get into in a sorted order, maintaining all these maintaining the condition that the direction at the end of the at the end of all these operations gets preserved. Like at the end of all these operations, the result each element should be facing towards the right, not towards the left. So we'll be seeing it now. First, what I'm going to do is 4, 3, 2, 5 is my initial array. First, I need to find the position of 4. So 4 should go to the third position right here. So I need to swap this 3 and 4, and 3 and 4. Now what these two. So initially 3 and 4 will be facing towards right. After getting swapped, their directions also will change, like it will also be left and left, right. So after that I'm going to swap 2 and 4. So 2 and 4, 4 is actually left and now it will be right, and 2 is actually right and now it will be left. So 3, 2, 4, 5 is my array, and I'm going to swap these 2, 3. So both 2 and 3 are left, and now it will be right. All these things will be right, and here also it is in decreasing order. So we got the increasing order. We got the array in a sorted order such that all the elements are facing towards the direction, right direction. So let's see our approach how to solve this problem. So first we need to understand that so for example, if we'll consider the second example, like 3, 3, 2, 2 is my given array, which I should get after doing some operations. I should get an array like this, right? So which is nothing but 2, 2, 3, 3, sorted array order of this like so. Now what we should do is I should move this 3 to either to this position or to this position, right, or to this position. So I should find a position where if I move to a position, whether to this position or to this position, where its direction is preserved. So if you look closely, if I do even number of operations on an element, so if I do even number of operations on an element, I can preserve the direction. If it is odd, I can't do it. Like so, what I'm going to do is, so here I'm going to summarize, like if if the position where I need to move, so number of positions I need to move, so position mod 2 equal to 0, then it is possible. Else, if I need to move to a position where it contains odd number of moves, it's not possible. So first this 3 will come here, right? So now this 3 will come here and this 3 will go here. So if this is the condition, then I can do this in say for example 2 operations. 2 is nothing but even, right? So in the first move it will be facing towards left, in the next move it will be facing towards right. So in this way, if the position number of positions I should move is even, then it is possible to move the number to its exact position, preserving the direction. So at the end of all the operations, it is still facing towards right. So if the number of positions I should move is even, then it is not possible. So this is the base case for our problem. So for example, what we are not going to do here is I'm going to move this 3 here. So first we will consider only these 3 are present. So okay, 3, 2. Okay, now my resultant array is something like this. I should get like this. But so I can either move this 3 to here or this 3 to here. But if I move this 3 to here, we have even number of operations. Like it will move here and it will move here. So we will go to this place in even number of operations. So our direction is again right here. So we should choose a position for an element such that the number of steps we should move is nothing but even. So if there is no such position where the number of steps involved is odd, so even, then it is not possible. So for example, now we have something like 1, 3, 2. Now 3 should go, only chances for 3 is to go here. So the number of steps that 3 should move is nothing but 1. So here we can't preserve the, say for example, we can't preserve the direction. So at the end it will be 1, 2, 3, but these 2 directions will be left, not right. So we can't form like something like that. So in this case it's not possible. So we need to print no. Okay, say we will take another example. This is our example 3, 2, 1. Our resultant array should be something like this. So 3, 2, 1. I'm going to move this 3 to here and 1 to here in 2 steps with this as my intermediary node. Okay, so this 2 will move, this 2 will also move 2 steps. So I will show you how it will move. 2, 3, 1. Now the sequence will be something like left, left, right. Now 2, 1, 3. Now it will be, we are swapping these 2, right? So left, right, left. Now I'm going to swap, sorry, it will be left, left, right. Now I'm going to swap these 2. 1, 2, 3. Right, right, right. So at the end of all the adequate number of operations, we preserve all these directions. So we can print yes for this condition. But now if I consider this 4, 2, 3, 1. So I'm going to consider this 4, 2, 3, 1 as my array. Here I need to move this 4 to its exact position, that is in the sorted order, 3 steps. 1, 2, 3. So here we are moving odd number of steps. So if we need to move odd number of steps, then our this direction will change to left, right. So we can get something like this. So 1, 2, 3, 4, but we will have this direction as left, this as right, this as right, and this as left. So here we need to move this 4 odd number of times. So we can't preserve the original direction, that is right. So we can only have left for these 2 elements. So this is not possible. So for an element, we need to find a position in the sorted array such that the distance between these two elements should be even. So if this condition satisfies for all the elements in the array, then we can say that it is possible. Else, if it gets violated for at least one element, we can say that it is no. So this is the basic approach behind this problem, and I have inserted my source code in the and I inserted my solution link in the description. Thanks for watching.